Welcome dear student, welcome to my channel Talking Physics with Piyas Sarkar. So in the previous day we shall taught about the projectile motion in horizontal direction. So today we shall know about the projectile motions with angular direction or a projectile thrown with a direction with the horizontal. So today's topic is angular projectile motion. So our today's topic is angular projectile. So if someone throw a particle with some angle with horizontal, we can know that we can choose x-axis as horizontal direction and y-axis as vertical direction. So if we throw a particle with velocity u with the horizontal, then it traces a parabolic path and then return to the ground after some time. We shall find out here the maximum height hm, total time of flight, horizontal distance covered, and also the path or trajectory. We shall find out the maximum height, which is denoted as hm, the horizontal distance, that is the distance between the point of projection and it strikes the ground, which is r. At maximum point set A, what is the value of time of flight, and what is the total time of flight, and what is the time taken to reach maximum height, which is known as TF. TF is the time taken to reach maximum height and TM is the total time. And we shall prove that the trajectory is parabola. So listen carefully, very carefully, okay? So in this case, as we say in the previous class, that physical independence of forces, that is the horizontal force which acts along x-axis is u cos theta remains unchanged throughout the motion. It does not change at any point. And here the vertical motion is u sin theta, vertical component of velocity is u sin theta at point O. After some time t, it reaches at point P, which is at a distance x and vertical distance y from the point of projection. So suppose at point P, this is the point P, the horizontal velocity is Vx. Suppose this is P, the horizontal velocity is Vx and vertical velocity is Vy. Now at point P, the horizontal velocity is always u cos theta as it is remain unchanged, and vertical velocity Vy equal to u sin theta. Here Vy is not equal to u sin theta. After time t, Vy has some certain value, we can prove it, that Vy equal to u sin theta minus gt, u sin theta minus gt, which t is the time to reach from point O to P. At maximum height, the vertical velocity is 0, that is Vy is 0. Here the Vy becomes 0, but it has a horizontal component Vx equal to u cos theta. So if you asked that at vertical point what is the velocity of the projectile, it is u cos theta, because here the velocity, vertical component of velocity is 0. Then it returns to ground, and if the direction of velocity here is v, therefore the horizontal velocity here is also Vx equal to u cos theta, and vertical velocity is in the downward direction Vy equal to v sin theta. This angle is also theta, and here the resultant velocity of Vx and Vy is along tangent position. This is known as V, which makes an angle beta with horizontal component of velocity. Now we draw a parallelogram in this point. So this is the full picture of trajectory motions. Okay, draw it in your exercise book. So if we summarize it in a word, we can get that the horizontal velocity becomes same, which is given as u cos theta at any point of the projection, but the vertical velocity is changes according to the time, according to the gravitational constant, and according to the initial velocity value. Okay, so vertical component of velocity becomes u sin theta at the initial position, then it decreases, and at maximum point the vertical component is 0, horizontal component remains u cos theta, and then after the point A, the vertical component becomes increase. So we can now find out this parameter value. Okay, so we can write out the value. I hope you understand my language. As I say this English very slowly, and I am not enough good in English, I am trying to understand you in my lecture through the language, English language. So at first we find out the trajectory. Suppose at time small t, the projectile reaches at P. So we can say that the x equal to u cos theta into t. X equal to u cos theta into t. Okay. Therefore, from here we can get the value of t equal to x divided by u cos theta. It comes out from the figure we draw earlier. At first draw this figure in your exercise book. Due to lack of space, I have to erase it or wipe it, but you have to watch the diagram first, then watch the equation for better understanding. So x equal to u cos theta into t, then at, and vertical distance y equal to given by v u plus at equation, we can get u is u sin theta. Here u means u sin theta, and here a is equal to minus g. It can be remembered a equal to minus g. So minus g into t, u sin theta minus g into t. Now y equal to, we can get that u sin theta minus gt value. Therefore, if we put the value of t, then what we can get? U sin theta minus g into t, that is x by u cos theta. U cos theta into t is equal to, so we can get the value of y equal to u sin theta minus gx by cos theta, and we can use the equation y equal to ut plus half at square also. Therefore, if we take the equation y equal to ut plus half at square, then y equal to ut, that is u sin theta multiplied by t minus half, or equal to plus half into minus g t square, ut plus half at square. Okay, so y equal to u sin theta, put the value of t, x by u cos theta minus half g t square, that is x square by u square cos square theta. u will be cancel out, then y equal to, we get sin theta by cos theta, that is tan theta multiplied by x minus g by twice u square cos square theta into x square. So again the vertical distance y is a quadratic function of x. This can be written as in terms of px minus qx square, which is nothing but an equation of projectile motion, equation of a parabola. So the diagram of any projectile motions follows parabolic path. Okay, understand? We can show the equation here. Next we go to the time at which the particle goes to maximum height, or the time needed to go the projectile to maximum height. For this we can get that it is known as Tf, and if we take total time of flight is Tm, then what is the relation between Tf and Tm? Tf is the maximum height, time taken to reach maximum height, and Tm is the total time of flight. So if we take v equal to u plus at equation, v equal to u plus at equation, then at maximum height v equal to 0, u equal to u sin of theta, a equal to minus g into t, we can know say Tf. Therefore Tf equal to u sin of theta divided by g. This is the time taken to reach maximum point. Okay, time taken to reach maximum point. And Tm is the time of flight, that is total time of the projectile, that is from the point of projection to strike the ground. Then for this Tm, we can say that if we take the diagram of projectile motion O to A, then here the vertical distance is what? Vertical distance is y equal to 0. Okay. Then vertical distance is 0, horizontal distance is x, but vertical distance, as they are on the same plane, then the vertical distance are 0. So from s equal to ut plus half at square, we can find out that s, that is the vertical distance, 0 equal to u means u of sin theta, t here is total time of flight Tm, plus half into minus g into Tm square. Okay. I hope you have no confusion. Therefore we can get that the value of Tm equal to, from this equation we can get twice u sin theta divided by g, which is simply the 2 into the time at which reach the maximum point. That is, if this point is maximum, then the time taken for the projectile to reach from O to A is u sin theta by g, and also this is time taken to coming down to the ground, u sin theta by g, because of the symmetrical nature of the parabolic path. This is a symmetrical. If we divide it in two half, the two half will be identical. So here the total time of flight is must be the twice of time of ascending and time of descending. Okay. Now we can find out the maximum height. So if you like my video, please subscribe. In the next day I will go with the numericals of projectile motions, different numericals, that is for objective MCQ and the MCQ for joint entrance examination. So let us take the maximum height. From the equation v square equal to u square plus 2as, at maximum height v equal to 0, u becomes u sine theta, that is the initial velocity in y direction, vertical direction, square, plus 2 g becomes minus g into h becomes h maximum. Therefore hm equal to u square sine square theta by twice g, u square sine square theta by twice g. Now we find out the horizontal range. This is the maximum height hm, o, a, b, and we can find out the horizontal range. That is, if a batsman standing here strike a ball in his bat, then at velocity u, then at what distance the ball strike the ground? Is it will be 6 or is it will be catch out? That is, it is either the inside the boundary or outside the boundary, depending on the velocity u. So we can write now the horizontal range r. R equal to, here we take horizontal direction, so we can get the horizontal velocity u cos theta. U sin theta is not taken here. Therefore r equal to u cos theta multiplied by which t? Now, as from here o to b, the total time taken, then you can taken here is the total time applied tm, which is tm. Now u cos theta, you can remember the value of tm, which is 2u sin theta by g. All the values you should be remembered. Okay. Therefore r equal to, we can rearrange it in this process, that u square into 2 sin theta cos theta by g, that is u square 2 sin theta cos theta means sine of 2 theta, sine 2 theta divided by g. So this is the range, this is the range, and this is the maximum height. Then what is the maximum range? What is the condition for maximum horizontal range? If theta 2 theta equal to 90 degree, then sine of 2 theta becomes 1. Okay, sine of 2 theta becomes 1, that is theta equal to 45 degree. Then range will be maximum, which is u square by g. Okay, sometimes we have to say in the question that maximum range, then we can put out this formula u square by g. So if a batsman hits a ball 45 degree with the horizontal, then it will cover maximum distance, or any javelin thrower athletic, or any stone we can throw out from down at an angle 45 degree with horizontal, it will goes maximum height. Now we can find out the velocity at any point. Velocity at any point, we can find out the velocity at any point. Okay, if this is the trajectory of the projectile motion, then we, after time t, it will goes to point p, as we say earlier, p equal to xy. Then what is the velocity of the resultant velocity of the projectile at point p? Okay, so velocity at any point, here the horizontal component is vx and vertical component is vy, but the resultant velocity along this direction v. Now what is the value of v? Okay, understand this clearly. What is the value of v? Obviously from the parallelogram law we can write that v equal to root under vx square plus vy square. You can know it from the vector, the magnitude of v, and beta, that is the direction of velocity tan beta, equal to v of y by v of x. This is beta, so this is perpendicular to base, that is vy by vx equal to tan beta. So we can know that v of x equal to u cos theta, v of y equal to what? U sin theta minus gt. Here v of y is not 0. Remember, v of y is 0 only at initial position, okay, and at maximum height, not at any point, okay. Here, not vy equal to 0. Therefore, v of y equal to u sin theta minus gt. Therefore, resultant velocity v becomes square of this, that is u cos theta square plus u of sin theta minus gt square. So you can get out the value u square cos square theta, and from this you can get u square sin square theta plus g square t square minus twice u gt sin theta. Okay, now u square cos square theta, u square sin square theta becomes u square, so we can get u square plus g square t square minus twice u gt sin theta. This is the resultant velocity, okay, and this is the magnitude of the velocity, and direction is tan beta, that is vy by vy equal to u sin theta minus gt by u cos theta. U cancel, that is beta equal to tan inverse u sin of theta minus of gt divided by cos theta. So at any point the resultant velocity becomes magnitude is this and direction is this. If we put t equal to, if we put at the end of the point, that is B point, the velocity, resultant velocity makes an angle theta, the direction is Vx equal to u cos theta, and direction of Vy equal to, in the negative direction, that is u sin theta, okay, u sin theta. So if we put here in the place of t equal to 2u sin theta by g, that is total, the value of total time of flight, then what is the velocity at B? If we put okay, we can wipe out this. If we put, because at point B the time is Tm, because it takes total time, so at point B, that is at the end point, it is called end point, where at which the particle strikes the ground, the resultant velocity v becomes, if we take Tm here, t equal to Tm equal to twice u sin theta by g, then we can get the velocity v becomes u and beta becomes minus theta. Do it yourself, okay. Beta equal to minus theta, velocity is u and beta equal to minus theta means the direction is opposite. Here the direction is upward and here the direction is downward, and the initial velocity and the particle returns with initial velocity with the same angle. This is the beauty of projectile motion, okay. So to this lecture I have learned you the everything about the theory of projectile motion. In the next video we can do it numericals. Please remember the equation, because we will directly put the equation value, okay. I hope you like my video. To know physics, please know physics properly or grow interest in physics, as I said earlier, please follow my channel, view my channel till the last end, and please subscribe for new watch video. Thank you.